Okay, sorry for disturbance. Okay, wait for 2 minutes. Okay, is it visible? Okay, now look over here. See this thing. This is the most crucial point. Be silent. Look over here. Can I write? See this. According to the right triangle, that is what is that? Vector law of triangle addition. Hey, look over here. According to that vector law of triangle addition, what was that? Resultant was equal to. Try to see this. Can I consider this to be as my resultant vector? Or yes or no? This can be written as what? See this. Is the vector of this head and head of this vector is matching or not? Tell me yes or no. So R PO prime will be positive or not, guys? Or yes or no? 100%. Plus what will happen? See this. Is this tail of this RPO is matching with the tail of RO prime O or not? Or yes or no? So is it going to be equal to R O prime O 100%? Yes or no? Now you see this. You got one of the biggest thing about the vectors is it automatically gives the result. Actually, you asked me now, like you guys didn't never ask me, sir, why we are studying vectors. For this reason, we are studying vectors because it can connect the moving observers and the stationary observer with simple equations. This was the reason vectors was first established. It was required when we rotate the coordinates, the magnitude should not change. For that reason, the vectors was coming. You try to see. Let's suppose if you have weight 56 kg over here. Your let's suppose if you have mass 56 kg over here. This mass should remain constant on the surface of moon also. Yes or no? How it will remain constant? If we do not have any kind of physical quantity to tell about that, it is not going to be constant. And vector was only physical quantity to tell about that thing. Are you able to understand me or not? So you try to see what it is saying. That what is this RPO representing? Distance of particle with respect to which kind of observer? A stationary observer. Yes or no? This was equal to what? This PO prime is representing what? Distance of particle. Distance of particle with respect to which kind of observer? Moving observer. What is this RO prime O is representing? Distance of not particle this time, distance of moving observer with respect to stationary observer. Are you able to get me or not? Or yes or no? Are you guys writing anything? Who will write, huh? Okay. Wait, listen this last point. After that, right? See, what it is saying that whenever you try to understand, whenever you want to calculate any kind of physical formation or any kind of physical quantity for an particle with respect to a stationary observer, this will be equal to actually the distance of the particle with respect to the moving observer plus distance of the moving observer with respect to the stationary observer. Got it or not? Or yes or no? Now you try to think, can I just take the derivative of this with respect to time or not? Or yes or no? Can I take the derivative, like what I can do? I can differentiate LHS and RHS with respect to time or not? What it will become? D by dt of R vector of PO. That will be equal to what? D by dt of R vector of PO prime plus D by dt of O prime with respect to R vector of O prime with respect to O. Are you able to get me or not? Can I take the derivative on LHS and RHS or not? Is yes or no? Or yes or no? What does this R vector is representing? Distance. You are taking the derivative with respect to what? Time. What is that? What is dx by dt? Velocity or not? Or yes or no? I can't hear. What is dx by dt? Velocity. Simple. Yes or no? So this is going to represent what? Velocity of particle P with respect to a stationary observer will be equal to velocity of particle with respect to moving observer plus velocity of moving observer with respect to the stationary observer. This is the total answer. That let's suppose, if you want, like let's suppose on this road, if I am saying, okay, wait, I'll take this as an example. I'll minimize this, no problem now. Is it visible or not? Okay, see this. Let's suppose on this road, if this car is here, if this person is here, okay, which is man, moving with some kind of velocity. Okay, this is velocity of man, I'm saying. Okay, now you have one car, guys, do not talk. Okay, now this car, on this car there is this observer which is moving with some kind of velocity v, so I'm calling this as velocity of car. Yes or no? Now we have one particular person standing over here on, or let's suppose this is the tree on which he is standing. So this is person sitting on tree. Okay, now I want to say, like, you are aware, you try to see this, you are aware of velocity of man with respect to which thing? Is it with respect to the car? No, na. It is with respect to what? It is with respect to this particular person who is sitting on the tree. Are you able to get me or not? Or yes or no? Yes or no? Tell me. Now, velocity of car is also known with respect to this person or not? Tell me yes or no. What you are aware? You are aware of velocity of man with respect to the tree, or we are velocity of man with respect to the tree, which is given by velocity of man. You are aware of velocity of car with respect to the tree, velocity of car with respect to the tree, which is given as velocity of car. But what you are not aware? You are not aware of the velocity of man with respect to the car. What that should be? I can just put this, all of these quantities in this relation or not? Or yes or no? What it will become? See this. What is velocity of person with respect to the stationary observer? It is equal to velocity of man. Or yes or no? Guys, okay, is equal to, now velocity of person with respect to the moving observer. Are you aware of this? No, you need to calculate this. Yes or no? You want to calculate the velocity of man with respect to the moving observer who is sitting in the car. So velocity of person with respect to moving observer is what? Velocity of man with respect to the car. Or yes or no? Plus, what is velocity of moving observer with respect to the stationary observer? That is velocity of car itself or not? Or yes or no? Vinay, you are not able to understand. See this. Try to. Hey, who are not able to understand? Tarun? Understood? You guess. You also. Okay. Now look over here. Again, I am telling. This man was walking. Till this example, are you able to understand this or not? With these variables, see what I am saying, that man is walking with some velocity. Car is traveling with some kind of velocity. There is a person who is standing on this ground, and that person is sitting on the tree. Got it or not? So actually, you tell me, the if I tell that man is walking with some velocity, I am doing this with some kind of a stationary observer or not? Tell me yes or no. So the man velocity with respect to this stationary observer, which is p, man velocity with respect to p, or man velocity with respect to the tree, is going to be equal to how much? Velocity of man itself. Or yes or no? Vinay, are you able to get me or not? Next thing is that velocity of car with respect to this stationary observer will be itself velocity of car or not? Tell me yes or no. But I want to know that what is the velocity of man. Let's suppose this is a Sundar Kanya. Okay, it has Kala, Choti or something like that. There is a KTM Sapri wala guy traveling in a Lamborghini and who want to cross by over here. So let's suppose I want to calculate the velocity of this man with respect to the car. How to calculate about it? So how to know about it? I'll just put this in relation. See this. Velocity of particle with respect to which observer? A stationary observer. Velocity of this man with respect to which observer? A stationary observer is equal to velocity of man itself or not? So I put it velocity of man. Next thing is what? Velocity of particle with respect to which observer? Moving observer. So velocity of man with respect to which observer? Moving observer is here car or not? So it will be what? Velocity of man with respect to car. Right or not? So this is I have put it velocity of man with respect to car. Next thing, this is what velocity of which observer? Moving observer with respect to a stationary observer. In this car, the person is moving or not? What is the velocity of it? Velocity of car itself. So velocity of car with respect to tree is what? Velocity of moving observer with respect to a stationary observer, which is equal to how much? Velocity of car. Or yes or no? This is what? Velocity of car. So what you got? Velocity of man with respect to the car is going to be equal to what? Vm minus of V of C. What you got? Vm minus V of C. Is this matching with some formula which you have learned? Or yes or no? When two objects are traveling in the similar direction, the relative velocity of one with respect to each other is equal to Vm minus of Vv. Or yes or no? Is this matching with your relation or not? Or yes or no? I can't hear. Are you able to get me or not? Why I am doing this? Why I went through this long process? Because in some questions, only two observers will not be there. There will be many observers, 3 or 4 observers. If you see JEE questions, there are 3 observers. Okay, and at that time you will be stuck. Okay, which observer? How we have learned the formula for 2 observers only. That 2 observers, they are moving in similar direction or opposite direction. I can calculate the velocity easily. But what will happen if there are 3 observers? 3 different observers, like this way. 3 different observers over there. You created one frame of reference, and based upon that you created this formula. So apply this formula. What is that formula? Velocity of particle with respect to, see this, velocity of particle with respect to a stationary observer will be equal to velocity of particle with respect to the moving observer plus velocity of moving observer with respect to the stationary observer. Got it or not? This is the whole relation which you need to follow for the relative velocity. Okay. Now, why I am calling this as a relative velocity? Because these equations can relate the particles velocity with respect to the observer, which are either at rest or which are either at motion. It can also tell the velocity of the moving observer with respect to the stationary observer, and that is why we are calling this topic as relative velocity. Why? Because we are finding the velocity of the particle with respect to something this time. Are you able to get me or not? Or yes or no? 100%? No doubt is there? No doubt now? Got it or not? Everyone? Okay. So it will be utilized. I'll see. I'll give the questions. Okay. Okay, write this fast. Write all the coefficients. What is V of PO means? Velocity of particle with respect to stationary observer. Velocity of PO prime is what? Velocity of particle with respect to moving observer. Okay. What is velocity of O prime means? Velocity of which observer? Moving observer with respect to stationary observer. Got it or not? Write this fast. Write this fast. Friday, all the questions I'll be doing. Okay. Friday and Saturday. Hey, who is that girl? Chaitanya. Beside you? Chinmay. Hey, sit straight. Your height is also short. Use speed height tablets. Okay. Can I move ahead? Sorry, Chaitanya. No problem now. Chaitanya? No. Those who are all sorts in this class use speed height tablets and Complan. Okay. I am Where is my slippers, huh? They want 8 number slippers? No, na? Okay. Can I move ahead? Can I move ahead? Okay. It's time to do some problems based upon this. Okay. Level 1 problems you have done. I'm going to directly to level 2. Okay. Means little bit awkward problems. Means it is a tragedy for you guys. Whenever I plan the classes, something will be definitely there. Yes or no? Okay, now look over here. Hey, listen. Two trains. Okay, two trains are there. Train A, okay, and train B. Listen me perfectly. Train A, train B. This one is of 100 meters length. What is the length of the train? 100 meter. What is the length of second train? 50 meters. Okay. One is 100, another one is 50. Okay. Next thing is, let's suppose this is A. Let's suppose the velocity of train A is how much? 20 meter per second. How much? 20 meter per second. And the velocity of car train B is how much? How much? How much I should put? 55 meter per second. Okay. One has velocity how much? 20 meter per second. Car B has velocity how much? 55 meter per second. You have to calculate, find the time in which car A crosses car B. Distance between them. Okay, I'm not taking any kind of distance between them. In which car A cross, in which train A crosses train B. Let me think. Let us think. Wait for some time. Do it fast. Wait. Yes, wait. Do this problem fast. Two trains are there. Train A, which is moving with velocity 20 meter per second. Train B, which is moving with velocity 55 meter per second. Train A is moving towards right and train B is moving towards left. You have to calculate the time in which train A crosses train B. Think ಮಾಡಿ ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಥಿಂಕ್ ಮಾಡಿ. ಇಟ್ ಇಸ್ ತುಂಬಾ ಈಸಿ ಪ್ರಾಬ್ಲಮ್. Two seconds. How many guys are saying 2 seconds? Ankit and all. 2 seconds. Okay, now look over here. I'm trying to calculate. Listen me. Hey. In this question, see. Listen. This man was traveling towards the right side. Car was also traveling towards the right side or not? Tell me yes or no. If this man starts to travel towards the left side, what I'm saying? If this man starts to travel towards the left side, this velocity of man with respect to car for the left side will become what? Velocity of man. See this. What it will become? Velocity of man will become negative or not? Why? Because it has started traveling towards the opposite direction. Are yes or no? So instead of considering velocity of man minus car, I can consider velocity of car minus man, and at that time it will become what? Velocity of car plus of velocity of man. Are you able to get me or not? So when two objects are moving in opposite direction, the relative velocity, the velocity of man with respect to the car will become what? Additive. What it will become? Additive. When they are in similar direction, the value will become what? Subtractive. Got it or not? So look over here. Two trains are moving in opposite direction now. Are moving in opposite direction or not? Now, if they want to cross, what is going to help? The velocity of A is also going to help. Velocity of B is also going to help or not? Tell me yes or no. Or yes or no. So at that time, if both the velocities are helping, you need to calculate the relative velocity or not. So what is the velocity of A with respect to B? It will be equal to velocity of train A plus velocity of train B. Or yes or no? What this will become? 55 plus 20, which is equal to how much? 75 meter per second. Now, to cross actually, is this distance is important? No. Hey, how is this distance important? Is this distance important? We are considering that this distance is negligible, means not important. Why? Because to cross actually, this car is over here, this car B is over here. Okay. So how much length is important? To actually cross, what should happen? The B should come over here and A should be here or not? Tell me yes or no. Then only it will be called as a total crossing or not. Tell me. So which distance is important? Actually the length of train A and length of train B is important if I am talking about crossing. Got it or not? Are I got it or not? So what is the length of train A? 100. What is the length of train B? 50. So total distance required to cross is how much? 150. Yes or no? So distance required is how much? 150 meters. So therefore, what should be the time required? Distance by velocity. Yes or no? And that is 150 by 75, which is equal to 2 seconds. How much it is required? 2 seconds. Are I got it or not? 100%. Write this fast. Write this fast. Anyone have HC Burma over here with them? Tarun? It's not there with you. Can I move ahead? Okay. So now till now we have done the relative velocity concept. Okay. Now I'm going to complete the theory part of projectile motion. Okay. I think how much time is left? In 10 minutes it is not possible to complete. One more problem. Okay. Now look over here. So let's suppose we have done this problem. Little bit we have done this problem. Okay. This is the best problem of HC Burma. Okay. See this. So on this car, on this road, there is a thief who is driving the KTM. Okay. It is moving with some it is moving with some kind of velocity v. Okay. Now behind that a police jeep is there. Police jeep Thar. Okay. It is moving with some kind of acceleration a. What is there? Acceleration a. Now it is said that initially, let's suppose the distance between them is how much? Let's suppose initially the distance between them is how much? Distance d. It is asked that after what time time police catches the catches the thief. Do it fast. You can do it using the one way which I did in the classroom and one using the relative velocity concept. Both of the concepts are applicable over here. Easy? Easy peasy, yes or no? Do it fast. Can you do it? What? Think, Madi. This is not that much simple. Okay, what should be the condition? What should be the condition? Are simple. Let's suppose in some time t, this KTM, this chapri guy travels this distance d. Okay. In some time t. What happened? This chapri guy travels some distance d in some how much time? T, or yes or no? In this time only, in this smaller time only, this police needs to travel how much distance? Hey, why this is becoming a snake? See this? This police needs to come over here at this point in this smaller time only or not? Tell me yes or no? Or yes or no? Then only the police will be able to catch the particular jeep, will this thief or not? Tell me yes or no? So in this time only, how much distance this police should travel? Distance of police. Have you watched that movie Simba? Simba la re ala. You didn't watch? Arey yaar, that. So distance of this, how much distance this police is traveling? How much? S plus, okay, I'm calling this as a smaller d plus capital D. Are yes or no? Is this police is traveling distance d plus capital D with what kind of acceleration? Let's suppose acceleration was having a at that time. Are yes or no? I consider that police started from the rest. Okay, so initial velocity of the police will be how much? 0. Or yes or no? Initial velocity is going to be how much? 0. Or yes or no? Now, for the thief, you write thief is traveling only distance d or not? Distance of the thief in time t is how much? Only distance, a smaller d. Or yes or no? Is this moving with acceleration? What is the acceleration, Chaitanya, of the thief? Tell me. What is the acceleration of the thief? Tell me. Disha, what is the acceleration of the thief? Huh? Ganesha, what is the acceleration of the thief? Huh? Why? What is the acceleration of the thief? Tarun? Abey yaar, this thief is moving with constant velocity v or not? Or yes or no? Array constant velocity, acceleration is what? 0. You have done it. Wait. So acceleration of this thief is how much? 0. Or yes or no? So you try to see in the time t, what is happening? This thief is traveling distance d, and in time t, the thief is traveling how? This police is traveling how much distance? D plus capital D. Or yes or no? So can you form the equation out of it? What will be the equation? Which equation this particular police will follow? Second equation of motion, S is equal to ut plus half at a square. D plus capital D is equal to what? Half acceleration is there and t square. Initial velocity is 0. So that's why I have termed that term to be equal to 0. Are you able to get me or not? Or yes or no? This equation, this particular thief is going to follow which equation? Distance is equal to speed into time or not? Tell me yes or no? Array, thief is going to follow that equation na? Why? Because acceleration is what? 0 this time. So distance is how much? D. What is the velocity of the thief? V into time t. Are you able to get me or not? Or yes or no? Can you form the quadratic equation out of here? Yes or no? Can we form the quadratic equation out of here or not? Can you do it? So look over here. See this. What is the concept? If you are going to solve a, listen me. If you are going to solve this normally, it will not give you the answer. It will not give you the answer. Why? Because t and t will get cancelled and all the terms will get cancelled and you will not get any kind of answer. Are you able to get me or not? So what to do? Sir, what to do at that time? Okay, my head is coming over here. So what to do at this time? You need to subtract one from another. So look over here. See this. D plus of D is equal to half at square. And this is what? D is equal to V into T. I can subtract both of these. What it will become? Half of at square minus of Vt is going to be equal to, wait, sorry, capital D. Yes, correct. Capital D over here. Okay. So that will be equal to what? Capital D only. Now you see this. Is it a quadratic equation? Is it a quadratic equation or not? Can you form every quadratic equation has two roots or not? Tell me yes or no. This time also t will be having some two roots and one will be negative, one will be positive. So I can consider the positive value as my answer. Simple. Or yes or no? Yes or no? So that is your procedure. HC Verma example number 8. Yes or no? Yes, you guys can go now. Okay. Are you able to get me or not? Those who want to write, they can write and after that they can go. Okay. Wait, I'll just stop the recording.